Hello everyone. So in this session we are going to discuss a method of non-destructive testing which is pulse ecosystem, right? Which is pulse ecosystem. So let us first understand this term. Pulse refers to the ultrasonic pulse that we are going to use in non-destructive testing. Echo means the reflected ultrasonic sound wave, right? So pulse ecosystem involves the principle, it is based on the principle of reflected sound waves, right? Which is also known as echo sounding. Okay, so what happens, as you can see in this diagram, a sample is being used, right? And you can see there is a small hole which is a defect basically in this sample. Suppose we want to identify this defect. Okay, so first of all we will be using a quartz crystal transducer, right? There will be a quartz crystal transducer. There will be a quartz crystal placed on the transducer. So with the help of piezoelectric transducer, with the help of piezoelectric oscillator, we will be using transducer to transmit, as well as there is only one transducer that will transmit and receive the ultrasonic waves. So there is a cable connected to CRO. CRO is cathode ray oscilloscope, right? Which is used as a screen as well as a timer, so that we can calculate the minute time between the reflected and incident sound wave. Okay. So you can see that first of all, suppose we are sending the ultrasonic waves where there is no defect. So AO, right, A0 or AO, right, is the region, okay, where the ultrasonic sound wave are being sent and there is no defect. So the sound wave will be reflected back and it will be received by the same transducer. Suppose you are sliding the transducer over the sample, right? Over the sample you are sliding the transducer. Also glycerin or oil is used so that proper contact is there and friction is not there between sample and transducer. Okay, so if you are suppose sending the ultrasonic wave where the defect is to be located, right? So AT is the region where the defect is there. So ultrasonic wave will be reflected from reflected back from that location only. Okay, right? If there is no defect, then ultrasonic wave will be reflected from the end of the sample. Okay, and if there is a defect, then the ultrasonic wave will be reflected back from the defect only. Okay, so what happens in flows, there is a change of medium and this produces reflection of ultrasonic at the cavities or cracks or holes or pores. So the reflected beam, that is known as echoes, is recorded using CRO, that is cathode ray oscilloscope. So the time interval between initial and final echoes depends upon the range of flow. And by examining echoes on CRO, flows can be detected and their sizes can also be estimated, right? So using the CRO, we can determine the time between the incident and reflected wave. So here I am showing you a screen of CRO, right? There is this white colored object is a sample that is being used to detect the location. Okay, and you can see there is a black hole in this object, in this sample, which is the defect that is to be located, right? So if you can see the transducer is sliding over the region where is no defect, right? Where there is no defect. So in the screen you are getting two waveform, you are getting two wave, right? You are getting two wave, right? One is from the top of the surface of the sample and another, the last one is from the end of the sample. Okay, from the end surface of the sample, as there is no defect in this region. Okay, so this is the digital display showing signal generated from sound reflecting off back surface. Now there is another screen, right, where defect, the transducer is sliding over where defect is there. Okay, so you can see in the digital screen now there are three waves, right? The third one between these two, right, between the previous two is showing that there is a defect. Okay, there is a presence of a defect. So this is the digital display showing the presence of a reflector midway through the material with lower amplitude back surface reflector. Okay, so from this you can see that there is a defect located on the sample, and from the time interval from the first wave and the second wave you can locate the region, right? We know that velocity is distance upon time. So using this equation we can easily locate the distance from the velocity of ultrasonic wave and time interval between these two waves, right? So the time, the measurement of time between the first wave and the second wave help us to know the distance of the defect from the top surface of the sample. So this is how defect is detected using pulse ecosystem. Okay, this is all about pulse ecosystem, which is a very simple system. Okay, so accurate measurements can be done, and defect can be easily located, right? And this method is really fast method. Okay, so now let us understand another method, which is through transmission system, also known as flaw detector. Okay, through transmission system is another method of non-destructive testing, and you can see these are the most basic components. There is a screen. This circle is basically a screen of CRT, CRO, cathode ray tube. Okay, signal amplifier, time base, pulse generator. These are the three most important components, right? Time base, right? It is time base. Okay, so first of all let us see the construction of this, let us see the block diagram of this method. There is a signal amplifier that amplifies the output that is being received by the receiving transducer. Okay, in this method two transducers are used. One transmits the ultrasonic wave, another receives ultrasonic signal, and the received signal is then being amplified by the signal amplifier. Time base is known as the heart of CRO. It is used to calculate, to measure the minute time between the reflected and incident sound wave. Pulse generator is used to generate the pulses of ultrasonic wave. Okay, so there is a screen. Okay, so this is the through transmission system. So as you can see, two transducers are used. One is used as a transmitter and another is used as a receiver. So first of all, pulse generator generates the ultrasonic signal. Then transmitter transmit the ultrasonic signal into the sample. Then you can see there is a small black dot into the blue sample, and capital D is there, which denotes defect. Okay. So if there is no defect, then the sample will be then the ultrasonic wave will be reflected from the back surface of the sample, and if there is a defect, then the ultrasonic wave will be reflected from the defect itself. Right, both this reflected wave are getting received by the receiver. Then this signal, output signal, is being amplified by using signal amplifier, and then it is sent back to CRO. Okay, so as you can see three waves in this CRO, right? Two waves are there. One is from the top surface, echo from B is from the back surface, and echo from D is basically the wave we are getting from the defect. Okay, so the time interval between two waves from the top surface and the bottom surface gives the thickness of the material, and the time interval between the top surface and the wave we are getting due to defect gives us the distance of the defect from the top surface of the sample. Okay, so this is through transmission system, right, using which ultrasonic waves can be accurately used to measure the to measure the time interval between two waves, and to detect the location of the defect, or to detect the size of the defect or crack. Okay, so through transmission system requires two transducers, one for transmitting and other for receiving sound waves. The transmitted ultrasonic waves gets reflected when they find a defect in the sample. Okay, so there are two types of defects. One is above the surface or on the surface, and one is below the surface. So cracks, blowholes, pores, all these are the defects that are known as below the surface defects. Above the surface, if there is a rough surface, there is a crack, right? While finishing or rolling the material, if there is any type of defect is there, then it is known as above the surface defects. Okay, so now let us learn some advantages and disadvantages of ultrasonic inspection method. Right, there are many advantages of this method. Okay, non-destructive testing is basically a type of ultrasonic inspection method. First of all, it is really cheap and it has high speed of operation. Then large size sample can be inspected in a very short time. Then location, nature, and even a size of a defect can be accurately determined. It is capable of finding extremely fine flaws. It can be used on magnetic as well as non-magnetic materials. Small objects with different weird awkward shapes can also be inspected. Power supply is not needed for some methods. This method required no great skill and easy to understand. Now there are also some limitations of ultrasonic method, such as no permanent record of the defect can be obtained. It can be observed only on the screen. Okay, so you have to do it again if you want to find the location of the defect again. Only skilled and well-trained technician can perform this testing, right? Also, sometimes what happens, defects that are just beneath the surface of the sample are sometimes not located or not detected. Okay, the deep-seated defect can be easily detected, but sometimes the defects that are just beneath the surface, right, can be not detected, right? So these are the advantages of and limitations of ultrasonic inspection method. So this is all about this session. Thank you.